Okay, we continue with another title for search strategy, which is reinforcement learning. Guys, reinforcement learning is a type of machine learning algorithm. It's very old. If you need some information, I've provided the link here. Just let's go. It's another block towards data sciences. Fantastic, guys. Applications of reinforcement learning in real world. So it's a very basic explanation of what reinforcement learning is and how you apply them in real world. What is the idea? So it's about agents and changing the environment. So reinforcement learning is basically, guys, trying to understand an environment by checking the outputs of the environment. So it is like you make an action to the environment and observe the results. So depending on the results, you make another action, you just learn it. And you do this continuously, and after some time, your agent understands that environment. Actually, reinforcement learning is something basic we humans always do. When we have something we don't know, we take an action to it. So imagine the very simple example is some games. You have a computer game and you don't know how to use it. You just push a button and something changes, you push another, and in time you understand it. Actually, it's reinforcement learning. Your learning is reinforced by the actions you take and by reading the outputs which depend on the actions you take. So it's very simple in other words. So how do we design and use it in CNNs? It's detailedly explained here. I'm just going to give you this idea. So it's one of the three basic machine learning paradigms. Because the machine learning paradigms which we can just provide is supervised learning and unsupervised learning. Supervised learning, it's a type of training we do. For each data, we have a label, and we learn those. Unsupervised learning is more like clustering. We look at the data, and we understand what the data is all about, but it's something in between them. You have the environment, you don't have labeled data, but you create your data and your labels. You make an action, you get a reaction. Action and reaction, so you're creating the data and you're creating the label. So it is both like unsupervised and supervised learning, because it is not supervised learning. There is no data which was labeled beforehand. You've only got the system. But it is not unsupervised because you're depending on the reactions that you get from the system environment. You're using it just like the labels of a data. So it's something in between. So it's the main thing here is the agent, the program, as we have seen here. So it's the agents. This is you guys, and this is the computer game. Just relating to that example. So it learns a behavior through trial and error interactions with a dynamic environment and maximize some reward. In your example, you're trying to just win the game, just learn the game, just get more points in the game. That's how you learn. Actually, reinforcement learning is a very high-level learning strategy for humans, guys. It's human-inspired technique, guys. So an agent performs some action according to some policy parameterized by theta. So you design that parameter. So you're trying to learn that game. Everybody will do something different. You'll just try something, then try something. Depending on it, you'll understand something and try another thing. Put another person in front of that game that also does not know anything about that game. That the other guy will try different things. So that difference between these guys is the parameter sets and the policy of these actions of those agents, guys, because they are implementing different structures of reinforcement learning. So the agent updates the policy each time what it's trying, and it will get a reward for that action. When I do this, I get more points. Okay, this must be about it, kind of. Okay, so how will we apply this to this idea? So this is a search strategy. We're going to apply this reinforcement learning here, and this will be the guy. This is the reward. This is the performance estimation. And by judging at these actions and reactions, it decides. So how do we just do this mathematically, guys? Actually, you make the search strategy just like a recurrent neural network. A recurrent neural network which gets inputs as the architectural space and outputs as the performance estimation. And the RNN, which is called the controller as well, will provide an architecture with probability P, if it's a probabilistic RNN, will be trained to get a performance, and depending on the performances you get previously, you calculate a gradient by some method and change the input that you provide to the RNN. So you get the gradient of, you analyze the change in the performance of different architectures and construct a gradient in your hand. It is just like saying, oh, when I do this, I get more points, so maybe I should keep on doing this, or maybe I should do this more often, kind of. It is like observing the change and making your actions depending on that change. So it's the gradient-based operation, but you are creating and calculating, and you are making a function relating to that gradient to your actions. It's a complicated matter, but this is all about reinforcement learning, guys. When you go into its details, you'll have to just learn machine learning, reinforcement learning, some optimization about it, and recurrent neural networks. You'll be able to construct strategies, and most methods, guys, in these neural architectural search field uses reinforcement learning, because it's pretty much high-level strategy, and actually finding an architecture is a high-level strategy. It's higher than finding the features, it is higher than finding the architectures, and it's a higher-level strategy. So it works fine with these methods. Okay, another idea is neuro-evolutionary approaches. It sounds so cool, guys. I mean, when I first hear about genetic algorithms or evolutionary search, they sound cool because it is like we are creating organisms, like cyber organisms. But it is useful, guys. So there's a nice blog. Let me just open it. As you can see, again, towards data science. I love this site. So what is deep neuroevolution, genetic algorithms, and blah blah, what they're about. If you're interested, just go and read this. Guys, to understand neuro-evolutionary approaches, we need to first understand what is evolutionary search. Evolutionary search, or evolutionary algorithms, they're a type of optimization algorithms, needless to say, because in this title, this search strategy title, what we are dealing with is always an optimization title. They are called genetic algorithms as well. They are also called genetic algorithms as well. They are based on the concept of Darwin's theory of evolution. Exactly. The Darwin's evolution theory is utilized in programming as genetic algorithms. In a genetic algorithm, you have a population of candidate solutions, just like the chromosomes. They are called individuals, creatures, or phenotypes, depending on the literature. They are fed to an optimization problem by evolving, by finding different combinations between them. You are trying to find a better solution. So in that sense, it looks like a reinforcement approach, but it's a bit different because you have this mechanism of mutation and modification. You mutate, and when you mutate, if you get good results, you continue on that line. So it is like creating a family of different evolved organisms. One line is better than the others, just like apes comes and they are better than the others. They're more smart. If you're trying to be smarter, if you're trying to be more stronger, then apes are good because orangutans are very powerful, whatever. So the architecture, the structure is a bit different compared to reinforcement learning because it is like the evolutionary programming. In the end, what optimization does is quite similar to each other. You change things and you get some results. The strategy you apply designates the type of optimization, guys. So each candidate solution has a set of properties. Properties means the chromosomes, the genotypes. In our case, the architectural parameters, the number of layers, etc., which can be altered or mutated, speaking in the evolutionary literature. So neuroevolution is a form of intelligence that uses evolutionary algorithms to generate artificial neural networks. Actually, before neural architectural search, creating artificial neural networks by evolution was studied. By the way, if you're interested in genetic algorithms, there's a nice YouTube video I found. This is MIT, Massachusetts Institute of Technology course on artificial intelligence. It's about genetic algorithms. Just visit and just watch it if you're interested. So neuroevolution is trying to find architectures by using genetic algorithms. It is used commonly as a part of reinforcement learning because reinforcement learning is like an umbrella algorithm. Inside reinforcement learning, you can try different strategies, gradient-based strategies or some evolutionary techniques. Usually, neuro-evolutionary techniques are contrasted with conventional deep learning techniques, just like gradient descent. So what I'm trying to say is you can use neuroevolution to find a proper architecture, but some studies, some researchers also use neuroevolution instead of gradient descent while training the system as well. Actually, some guys from, as far as I remember, Uber, that driving company, they've been doing research. It's the paper, just the series of papers they have. These guys work on deep neuroevolution a lot, and they say that let's wait for the paper. I'm not sure it's going to retrieve the paper, so let's not wait for it. So in those papers, they suggest that simple structural neuroevolution algorithms can be competitive with sophisticated modern industry standard gradient descent algorithms that we use in training. So neuroevolution can be used in high-level reinforcement learning for neuro-architectural search and as well as for training instead of gradient descent. So neuroevolution is very useful and being studied. Just you can start, but I visited this site, so don't worry. You will just, if you try some other time, you'll be able to get this paper. Okay. Let's continue in the next slide.